Here's a problem from chapter 26. It asks you to evaluate the integral from 1 to 2 of x cubed dx. Now that's a calculus problem that can be stated like this instead. What is the area above the x-axis between the line x equals 1 and x equals 2 and under the curve y equals x cubed? And so this diagram right here is exactly the same problem as this problem over here. So the first step to do would be to, if it's stated like this, to write it like this. Now, in order to solve this problem, we learned one rule, which is that you take this x cubed, you take the 3 and add 1 to it, and write x fourth over 4, and that's the answer. Except that we have to do the answer, we have to plug in two numbers, those the 1 and the 2, so I'm going to write the 1 and the 2 right there to remind myself. I'm going to plug in the 2 and then plug in the 1 and subtract and find the difference. So I plug in the 2 to the 4th over 4, and then I plug in the 1 to the 4th over 4, and I get 16 over 4 minus 1 over 4, which is 15 over 4. So the key step in this kind of problem is remembering to take, if you have an x to the 3rd, you translate it, or the solution is x to the 4th divided by 4. If it's x squared, it's x to the 3rd, so you just add 1, x to the 3rd over 3, and so on.